Good evening, everyone. I welcome you back to my YouTube channel. Presenting before you this wonderful tutorial is Hampio Kliman. And to those of you that are new to this channel, consider subscribing, hitting the like button, and also sharing to others. Okay, let's do vector analysis as an introduction in this tutorial. Let's get started. What is a vector? A vector is a quantity that has both direction and magnitude. So when we say direction and magnitude, what do we mean? A very good example is velocity. We can say that a vehicle is simply moving at a speed of 20 meters per second. "20 meters per second signifies two things: the magnitude, the direction. The same thing is true for the acceleration, because acceleration can also be written just like velocity. So we can have 2.0 meters per second squared. The 2 is simply the magnitude, meters per second is the direction. And of course, vectors are simply one amongst the two quantities that we have under physics. We also have scalar quantities, but we won't go deep into that. But a very good example of a scalar quantity is simply temperature. Another good example that I can give as an example of vectors is simply the force, because we know that force is measured in newtons, and the newton can be broken down into its particular SI units. So you can have 20 newtons, right, like that. This is simply the magnitude and the direction. All right. Let's proceed. Now look at this. A vector quantity in handwritten form can be represented by a letter with that letter containing an arrow, like this. So the arrow on top simply tells you where the vector is moving, and it's very important to highlight that. Very good example is this particular diagram. For example, let me just use another pen. All right, let's say that what we have here is simply A as a vector, and what we have here is simply B also as a vector. How do we find the hypotenuse or the long line? The long line in this case is simply the resultant vector. Resultant vector is simply represented by the letter R, and it can be written as the summation of all the vectors, which is simply A and B. So this can also be written as A vector plus B vector. And of course, that is just how we present vectors under this topic. All right. So in this case, R is simply representing what we call the resultant vector. And it's very important. It's very important to take note of this. It's a very important factor. All right. Now, vectors undergo what we call addition and subtraction. What does it mean to add vectors? What does it mean to subtract vectors? Well, let's try out these examples. Two vectors can be added, particularly they have the same direction, or they may have the different direction. But two vectors are said to be equal if they have the same magnitude and direction. In this case, vector A is simply 40 kilometers east, B is 10 kilometers due west. So if we were to draw this on the line, this is our west, this becomes our east, this becomes our north and our south. B is simply 10 kilometers west. So in this case, it will attain a negative direction. A is simply 40 kilometers east. And in this case, it will attain a positive direction because we move in this direction. So, to answer the first question, A vector plus B vector is simply negative 10 plus 40. And of course, this will give us 30.0 kilometers east. And that becomes our final answer. Very easy. Okay, so that becomes our final answer. Let's try out the second question. The second question is simply saying we find A minus B vector. We can use the same procedure. In this case, we know that A is simply 40 kilometers minus B, we know that is negative 10 kilometers. So this is going to be 40 plus 10. And of course, we have 50.0 kilometers. The biggest number takes position, so this is going to be east. B, the second question simply states, if an addition of vector C of 20 kilometers to east is added, find A plus C. Let me just try to grab the board. We see how we can solve this particular question. So vectors are very simple. It's just you having an understanding. Now, so A is simply, we're doing 2A. So A is simply positive 40 due east, plus C is simply 20 east. And of course, this will be 60.0 kilometers. This makes sense. 2B, we have been taught to find B plus C. And of course, we know that B is simply negative 10 plus C is simply 20. So we are going to find a 10.0 kilometers. So it's just you having an understanding concerning this. So vectors can be added, vectors can be subtracted. And what is important is just the direction. When you get to know the direction, you get to know it becomes easy to deal with the magnitude. Alright, let's now do something that is very important, which we'll now call as vector components. Now, suppose we have this x or y plane. We know that this is the x axis. This, of course, then becomes the y axis. Notice that if A is our resultant vector, okay, if A is simply our resultant vector, which we can name as A like that, A vector like that, then it means that this A vector is going to have what we call components, particularly in the x and y direction. It's very important to take note of that, where a vector is equivalent to the resultant vector. Now, how do you come up with those components? Let's make simple calculations. In the x-axis, a vector is going to have this particular component. So let me just do this. Let me try to put everything neatly. Okay, let me do this so that this one becomes the y component. All right, so now look at this. We can say that this is going to be the x-axis. This is going to be the y-axis. Let me just try to use another pen. Okay, so in the x-axis, vector component A is going to equal to A cosine the angle theta, where that angle is simply this angle here. That's the angle theta. And of course, this applies in the x-axis. It applies in the x-axis. This applies in the x-axis. In the y-axis, A vector is going to equal to the same vector component given, sine the angle theta, and of course this applies in the y-axis. So in this case, in the y-axis, we shall have A cosine the angle theta. That is a vector. Equaling that. In the y-axis, we are going to have a vector equaling a sine the angle theta. So if you want to find the component of A in the x, you use this particular concept. Okay, so this is going to be a vector in the x. That's the x component of this particular resultant vector. And if you want to find a vector in the y, which is the y component, it means you use this particular formula. So make sure you take note of that. Now, how do you find the resultant vector? Just in case maybe you have been given the components. Let's try to do everything here. So look at this. In the y-axis, let me just say in the x-axis, we said that the x component of vector A is equal to the resultant vector cosine the angle theta. In the y-axis, the y component of A is simply the resultant vector A sine the angle theta. You use these formulas whenever you have been given the resultant vector, then the theta, then automatically you can find the components. But in a case where you have been given the components, we use the Pythagoras theorem. How does the Pythagoras theorem come about? If you have a triangle of this kind, this is your resultant vector A. We know that this can also be written in this form, and of course this becomes our y-axis, this becomes our x-axis, this becomes our theta. We know that this is going to be A, B, and C. So we know that if we want to find this guy here, then it means that we have to say A vector power 2 is going to equal to AB plus BC, then we say square root of that. So our A vector as a resultant is going to equal to the square root of AB power 2 plus BC power 2. So in this case, I can just simplify everything by simply saying the resultant vector can be found using this formula: A power 2 plus B power 2, where A and B are components of the resultant vector. R, A, not R but A. Now look at this. This formula is the one that we should use to find the vector, the resultant vector, given the components. How about if you want to find the angle or the direction? To find the direction, we simply use this formula. Direction is simply theta equal to, this is going to be, look at this. Tan theta is equal to adjacent supposed to be opposite. Trying to remember the trigonometric functions. So let me just try to write this SOHCAHTOA. It's very important to remember this. So it's going to be opposite over the adjacent. Now look at this. Tan theta is going to equal to, which one is the opposite? Y-axis. So it's going to be the vector component in the y over the adjacent, in this case is simply this one, over the a component in the x. Now look at this. We want to find theta. So in this case, we will say theta is going to equal to tan inverse of the y component over the x component. And of course, this is the formula that applies. If you find this video interesting, consider subscribing and also hitting the like button. In our next tutorial, we shall be solving different questions concerning this. Thank you so much.